This talk is the first one in a series on physical considerations. Physical considerations being those things that have to deal with the physical world, physics, gravity, rain, wind, water, nature. How do those things impact the way architecture comes to be, and what are the challenges of architecture in dealing with the physical world? So if you'll recall, back a number of talks ago, I introduced what we refer to as the Vitruvian triad. That's firmness, commodity, and delight. It's where this Roman architect said that's kind of the picture of what architecture is. It's a combination of dealing with firmness, commodity, delight. And I mentioned that we're kind of reframing that in this class, thinking of those same notions, but now trying to use terms that are more appropriate in a 21st century setting, where we expect a lot more of architecture than they did in Roman times. So I mentioned that we would be converting the term firmness to physical considerations, a little broader terminology. Commodity would become all sorts of human factors, and delight would become issues of form. So in the past talks recently, we've been talking about issues of form, and at this point we're transitioning into that notion of firmness now, in our terms, physical considerations as they shape buildings. So in some ways, this was where architecture began, with physical considerations. It was people thinking, I need shelter, I need to get out of the rain. And firmness was an appropriate term because it was like, it needs to stand up, it needs to be firm. I need to be able to depend on this to shelter me. So in the very most primitive of cultures, architecture is almost totally about firmness or about physical considerations. And then over time, those physical considerations have expanded and expanded. Even in Roman times, they weren't worried about keeping buildings hot or cold particularly, a little bit, but they certainly weren't very temperate in that era. But in our own time, oh my gosh, we think we have to be at 68 degrees in the summertime, and we have to be perfectly temperate. So we make much bigger demands thermally on buildings. Also in the 21st century, we're now beginning to understand the impact that architecture and other things have on things like global warming, things like changing ecology, things like resource consumption. All of these are physical considerations. What is it in the act of building that affects the ecology of the world, that affects the performative nature of the world? All of those are physical considerations, and that's a part of what we're looking at in this segment as well. So we'll have, again, a number of talks. Those talks will be on topics like how the land itself, the physical considerations of the land shape building. There'll be talks on geography and topography and ecology and how buildings either work with or against patterns of rainfall and drainage and flooding and issues like that. We'll be talking about the actual construction of buildings, the construction process, how we make them. That's a physical consideration. We'll be talking about structure, that notion of firmness, how do buildings stand up, and how does that affect the actual architecture of the building, and the materials that are appropriate for resisting the forces of gravity and the forces of wind and other loads on a building. We'll also be having a pretty extensive discussion on climate. How does the sun and other kind of climatic issues affect the way we make buildings? So it's a whole series of issues about physical considerations. Now, I think as an introduction here, I'd just like to talk briefly about 5 big issues today, things that are so much on our mind today that are right in this part of the class, and reasons why maybe today, just as in ancient times, physical considerations were the seminal element of architecture. In some ways today, these 5 issues make physical considerations a very, very fundamental and important part of making architecture in the 21st century, because we have to address these issues that are really beating on us at the moment. And I think for a few minutes here, I'm going to maybe try to scare the bejesus out of you, just to let you see, man, if architecture doesn't address these physical considerations issues, we're going to be even in deeper trouble than we have been in the past. So these are things we absolutely have to start dealing with. So the first of these is energy consumption. So I'm sure everybody is conscious of the problems created by burning hydrocarbons and by energy consumption in most of the ways we do it in contemporary world in the 21st century. So when you get your big gas guzzling SUV, you drive it in the gas station, you pull the pump off, you stick it in, you pull the lever, and you can just see that gas guzzling into your car. You can smell it. You know I'm consuming fossil fuel here, and it's very palpable. And the more you use, the more you begin to understand what energy consumption is about in your car. But all of transportation only accounts for about 30% of our consumption of energy in the United States. 50% of our consumption of energy is in buildings. And actually, we sit in buildings all the time. We're feeling perfectly comfortable. And we're completely unconscious of the amount of energy being consumed to keep us comfortable. We don't see it like we see that nozzle going into our automobile, but it's sitting there consuming energy in an extraordinary way. So all of the issues associated with energy consumption, and especially the consumption of fossil fuels, things like greenhouse gases, things like air pollution, things like resource reduction, all of those things are issues that buildings impact. So we can make our buildings more energy efficient. We're reducing the use of fossil fuel. We're reducing the use of fossil fuel. We're reducing the problems created by greenhouse gases. We're reducing pollution, all kinds of other things. So one huge issue we have to be considering in buildings is what kind of energy consumption do they have? A second issue has to do with just the making of buildings and the kind of consumption of all kinds of things that go into creating buildings. So if you see wood in a building, it's very beautiful, warm, it's great, but somewhere a tree had to be cut down. Perhaps a forest was decimated in order to get that timber for that tree, for that purpose. Sometimes that tree was farmed. Sometimes that tree is an exotic, tropical forest tree, and it may be having big impact on ecology or in global warming in Brazil. But the use of that wood resource can have implications as well. And that's true of almost anything you make a building with. Steel is incredibly energy consuming because you have to take that iron ore and take that coal and put it all together, and you have to smelt it at a very high temperature, and all of that is creating pollution and using fossil fuel, and all of those same things that we worry about in energy consumption, we have to worry about that in the making of building materials like steel or aluminum. Oddly enough, we look at this and we call it embodied energy, how much energy is needed to make the building. And steel has pretty high embodied energy, but reinforced concrete has even higher embodied energy. And when you're mining that Portland cement to make that concrete, you're also sometimes kind of strip mining whole sides of hillsides, and there's an implication that goes with that as well. Copper, which we use a lot in buildings. The extraction methods of copper can be incredibly polluting. So that's a certain kind of physical consideration we have to worry about too. So there are many, many other resources we use in building that are consuming and destroying and having an impact that we need to take into consideration when we're making architecture as well. So the first thing is energy consumption. The second thing is consumption of all of these other resources in making buildings. A third kind of consumption is actually consumption of land. Because when a city's expanding and it's growing and we're building more buildings on what was more virgin land, that's also a resource that maybe we can't just neglect. So for example, if that used to be a forest and now you're felling the forest and you're making a subdivision there, that is having an effect on greenhouse gases. It's perhaps having an effect on wildlife and habitat, ecological impacts that we have to be concerned about. It may well create greater runoff. There may be flooding that's created by the decimation of that forest because it was slowing down water runoff, because it was stabilizing soil and reducing erosion. All of those things become factors when we're consuming land. Sometimes we consume land that used to be farmland. Now we're reducing our amount of land available for production of food. That's another kind of concern we need to have. So any kind of land consumption is also an issue we need to be thinking about in a world where the population is increasing and the urbanization and the buildings are increasing as well. A fourth issue we need to be concerned about is toxicity. There are building materials that, when they're new and they seem great and wonderful, and then later on we found out, oh my God, that causes cancer, like asbestos does, which very popular building material in the 50s and 60s. Now, death. It's a horrible, horrible material. So we have to worry about, are we making building materials that actually have that kind of deadly toxicity? But also there's milder kind of toxicity. Many building materials, especially carpets on the floor, are made of hydrocarbons. They often have off-gassing that creates a kind of indoor air pollutant. We're sitting there breathing that air. What kind of effect does that have on our health? Fabrics and upholstery, acoustical ceilings, which are everywhere, those little grids of acoustical ceiling. Those are made out of a lot of materials that you really don't much want to think about, with really long chemical names that also have off-gassing and can sometimes create indoor air pollution. For many years, I was on a board of a nonprofit called Green Guard that's really about trying to reduce indoor air pollution, increase indoor air quality. These nonprofits are there to safeguard our health against the kind of pollution that can be created in indoor environments. So especially as we make our buildings more airtight in order to make them more energy efficient, it means that there's less exchange of infiltrating air with the air in the air we breathe. And that air we breathe then can have a lot more pollutants in it. The rise of asthma in the United States is often attributed to the fact that we spend so much time indoors, and because the quality of the air indoors is affected by all these chemicals that are in building materials, and that they're having an effect on our health. So toxicity is another big issue we have to be concerned about. And then the fifth and final issue is waste. So we're all very conscious about recycling our Coke cans or our paper or whatever, as we should be. But if you think of the amount of waste that's produced in a construction site, and the fact that that goes to the same landfill that our domestic waste goes to, only the quantities are much, much, much bigger. If you look at those dumpsters on a construction site and the fact they empty them often every day, and you realize, oh my gosh, the amount of landfill that's being created here is extraordinary. And again, if designed properly for any of these things, you can reduce the amount of waste by proper architectural design. You can reduce the amount of toxicity by being careful about what materials you're using and what kind of indoor air quality you're creating. You can reduce the impact of land consumption by looking at greater densities and smaller footprints of buildings. You can reduce the amount of consumption of other kinds of resources by being careful about are you getting that wood from a farmed resource or from a virgin forest. You can certainly impact through architectural design the kind of energy consumption a building has. So all of these things that we're talking about of big environmental issues today, these are things that we're going to be dealing with as we talk about physical considerations in the next few talks. So for a moment here, I want us to look at an example of a culture that kind of got it right, that is taking all of these physical considerations into account and is making a very beautiful and very rich environment that avoids the problems created by some of these issues. So the example I want us to talk about is 3 little mountain villages in the southern part of China. And these are mountain villages that have been there for generations and generations and generations. Actually, when I visited there a decade or so ago, there were still not roads in this part of southern China. So you can't get to these places by a vehicle. Instead, you hike into these villages, and they're pretty much cut off from most of the rest of the world. There are very few people who interact with these villages from the outside. And they're really pretty amazing places because they've been sustainable, they've been resilient over generations, really just applying some very simple principles related to physical considerations that have made them healthy and productive over a long period of time. So the terrain in this part of China is actually very beautiful and very dramatic. It's way up in the mountains and at a fairly high altitude. Very, very rugged terrain. You can kind of understand why they haven't put roads in here because it's very difficult to put roads in. But it's an agricultural community primarily, and their primary crop is rice. So they have done several things that make a lot of sense. Where the land is steeper up here, they have left the forest completely intact. And that allows them to have some areas where they can have wildlife that they find useful for their culture and have left it completely unspoiled. And then there are other areas that are just a little less steep than these areas that they have then made into their fields. And they've made them productive by creating these terraces. And those are actually just made by dried mud brick walls that they use as retaining walls. And then it's a very elaborate system of hydrology and terracing that allows them to get these fields that they can flood, and they can plant their rice in there, and then it grows and they harvest it without really radical alteration of the topography of the area. So that inhabitation for farming is very ecologically sound. And then within that, when they put a building in here, they take really the same attitude as they do with their terraces. They slide it along the contours so that they're making just as little disruption of the topography of the area as possible. And they're really, their transportation kind of has the minimum impact. Like I said, not so much big roads and cars. They travel primarily by foot. In fact, when I was there, and this changed radically, I understand, even in the last 10 years, but they really didn't use wheeled things very much because the terrain is so steep, it's really not practical to use the wheel. So things are just with steps and these walkways through the woods. And then the buildings themselves are made out of materials that they took from the land and were actually complementary to their farming. So when they had to fell the trees in order to create those terraces, they used that wood for building their homes. And that becomes a very natural and authentic resource for them there. And they use absolutely every bit of the wood. They use the heavy timbers, the big pieces of wood for the frame and for the structure, and then they use smaller pieces of wood for infill. They even use the branches for thatch, for roofs sometimes. So they're using every bit of that tree. They're also making their roofs sometimes out of clay tiles. And that again is just taking the mud, the clay mud from the soil. They sort of shape it around their thigh. And I saw them doing that, just patting it on their thigh. And then they take it off and they put it on a mold that then they put in the sun, and they sun dry that clay, and it makes a kind of pottery. And then they turn one up and one down to make these barrel tiles like that. And that's their roofing material right there. So that comes to the ground, the wood comes from the trees around. This was a building they were actually building. This is fairly recently. And they're using the methods they've always used, which was actually not to use nails or bolts, but instead to use mortise and tenon, where they make a hole through one big piece of wood and they stick the other piece in, and that makes a slotted joint that is really good structurally. And that way they don't have to rely on any resources from outside, because obviously they don't have iron ore, they don't make steel, they don't make metals that they would use for the nails. So that was a building that they were building at the time, just a decade or so ago. Their traditional house there is just, this one blows me away. It's just so smart. And I'm not saying we should build like this, but I am saying we should build this smart, and we often don't. But in this case, this is their home, but it's also kind of a barn. So they have very, very cold winters, and they have to keep their stock inside in the winter. And then they have really hot summers and very humid. So that's another kind of challenge. And of course, they don't have air conditioning or any kind of fuel used for that. Their stock stay here in the wintertime. That's kind of the barn, the stables. And so they're down here, and they're in fairly close quarters, these cows and horses and pigs down here. And they're generating body heat. And because they're in pretty close quarters, it's a fair amount of body heat. And that warm air rises, and it heats the place where the people live right above. So they're getting natural heating from the stock down below. Then they take their rice and grains and other crops, and they store them on top of their house right here. And that actually creates insulation. It's very effective insulation. So for the winter, they harvest in the fall, they put all this in there, and over the winter time, they've got this perfect insulation. So they've got the heat from below, the insulation above, and a pretty temperate space for their inhabitation in between. They also have ventilation of that attic space up there. That makes sure that the grain doesn't mildew or doesn't get wet up there. It allows constant kind of breeze that goes across there and ventilates that. And then this is kind of a shelter on the top. And in the summertime, when it's blazing hot, you can see that big overhang, a big kind of like wearing a big hat, and then it ventilates below so that you don't get the sun beating down on the roof of your house and creating greater heat inside the house there. Everything about the design of that house is just so smart and so simple, and using physical considerations. How do I get the right heat? How do I get the right cool? How do I use the right materials? Things like that. Now, I don't know, for my money, it gets to be quite beautiful sometimes here too. It's not homely, but mostly they're building things in a very, very practical way that is based on physical considerations. That'd be another one of those homes with a kind of stock down here, the family up here, and then this ventilated attic that's up above it, up there. So they figured out an indigenous way of building that makes sense, and they apply it in many different ways. Then, like I said, sometimes their roadways are actually quite beautiful and made out of stones they could pull out of the field, and they can dress and make a very good roadway through there. They almost always are, like I said, carrying things either on beasts of burden or carrying it themselves, and they're walking pretty much everywhere. There are little agglomerations of villages that happen where they have a little bit of trade of goods, and they're lovely, kind of quaint villages like that up in the mountains as well. There's something wonderful about just that really responsible use of resources. Always thinking, what do I have at ready available to me? So if I pull the stones out of my field, can I use them to make a retaining wall? If I am going to harvest that wood, I'm really using it to do something else, but always thinking about a larger recycling of all the resources they're dealing with. This is a little carved stone that's in one of those villages. The three villages are kind of associated with each other. This is an emblem they use to represent the three villages, all of them being independent fish, but sharing a head so that they're in it together. And they manage the resources, so they're not spoiling the neighbor's stream that are downstream from them there. They're not using resources that a neighboring village may need in the long run. All of those things are being done in a kind of cooperative and supportive way. So I would say in this section on physical considerations, a lot of what we're dealing with here is really just how do we manage resources? How do we deal with rain and wind and sun and heat and cold and structure and keeping buildings standing up and using the right construction materials and putting them together in the right way, in ways that are ecologically sound, in ways that are economical, and in ways that in the end make beautiful, amenable environments as well. Okay, see you next time.